Hello and welcome to peace sign, wise, a wise owl, plus f of x stands for functions, piecewise functions. Okay, so if you take out your notes, you'll need 3 pieces of graph paper if you don't have graph paper in your notebook, and then you'll need a pencil and a calculator. And remember, you can always get graph paper off my website if you need to. Okay, so what are piecewise functions? A piecewise function is a function that is made up of pieces of different functions or different graphs. And how I know that they are just pieces is because I will tell you what x values I want you to use. So I might tell you to use every x value greater than 3, or I might say every x value less than 3. Now, because I'm using the word less than or greater than or equal to, lots of students think that these guys are inequalities. But let me tell you, they are not inequalities. There is no shading and no dashed lines or dotted lines. They are simply pieces of different graphs where I tell you which x values to use. And those are the only x values of that graph that you will graph. Okay? One thing that you'll see today is you will also see an f of x. That means a function. It's read like this, f of x. Now, it's basically just a y. So if I said y equals 2x plus 3, I could also say f of x equals 2x plus 3. The f of x is another way of saying y. And I think I talked about that in class last week, but I just wanted to make sure that you remembered that f of x is the same thing as y. All right, so we are going to graph this piecewise function. It says f of x is equal to 1x minus 4 if x is less than 3. And then it says also I want you to graph a piece of a different function, 2x plus 1, if x is greater than or equal to 3. So what you need to know is that these are just to tell us which x's we use, which x values we will use. Okay? It doesn't tell us that we're going to have dotted lines or solid lines. It basically tells us which x values we're going to use. So let's go ahead and do the first function. And I'm going to do that one in red. So I'm going to make a t-chart, x values, and I'm going to write y is equal to x minus 4 or 1x minus 4. And it tells me that the values that I'm going to plug in my table are going to be 3 and less. So 3, 2, 1. Now, because it says less than 3, just like when we did inequalities, absolute value inequalities and regular inequalities and compound inequalities, that symbol meant we were going to have an open circle or a closed circle. So we are going to have an open dot at 3. Okay? Now let's plug it into our function. 3 minus 4 is a negative 1. Plug it back into this function here, and 2 subtract 4 is negative 2. 1 subtract 4 is negative 3. And then I go over to my graph and I graph that function. Now I could keep going, but I'm just going to do 3 points. So 3, negative 1, open circle, 2, negative 2, 1, negative 3, and I could also do 0, which would be negative 4, but you can see that everything that I want to graph for this function is to the left of 3, everything less than 3. Now, if I didn't tell you I wanted less than 3, I would graph the whole line all the way across the graph paper, And I wouldn't use an open circle. I'd just make a point everywhere I needed to go, and I'd have arrows on both ends. But I only want this piece of the graph, okay? So now I want another graph, and I want a piece of that graph. So I'm going to make my x and y table. Y equals 2x plus 1. And this time, I want everything greater than or equal to 3. So I want 3. But this time, I don't want 3 to be an open circle. I want it to be a closed circle because it's greater than or equal to. And if you remember in inequalities, the equal meant closed dot. Okay, and then I want values that are greater than 3, so 4 and 5. And I could keep going if I wanted to, but we'll just do these and then draw our arrow in that direction. So 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. 2 times 5 plus 1 is 11. Okay, so I'm going to graph, oops, something went wrong with my board all of a sudden. Just gonna make sure that I can still write on it. There we go, sorry about that. And so 2 times 5 plus 1 is 11. And so I'm gonna plot these points. 3, 7, closed circle, 4, 9, and I can't really do 5, 11 anyway, but I know that the graph is going to keep going in that direction, and so I'll draw the arrow pointing in that direction. Now that is what we call a piecewise function. It's a piece of one graph and it's a piece of another graph, okay? Telling me what values of x I'm going to use. Let's do another one. This time I'm going to do f of x, or y, equals the absolute value of x minus 3 if x is less than 5. Remember, these just tell us which values of x I'm going to use. It doesn't tell me that I'm going to have shading or an inequality. It just tells me what values of x I'm going to plug into my table. Okay, so I am going to graph the first one, the absolute value of x minus 3 if x is less than 5. So I'm going to make my table. Okay, and I'm going to plug in values that are less than 5. So 5, 4, 3. 5 is going to be an open circle. Okay, and I'm going to plug 5 in there. 5 minus 3 is 2. The absolute value of 2 is 2. 4 minus 3 is 1. The absolute value of 1 is 1. 3 minus 3 is 0. The absolute value of 3 is 0. Now, we have to be very careful when we graph absolute values. Because if we don't graph the whole graph or the graph that has part of the vertex, we might not see the whole graph. So what would be the vertex of this graph? Remember how I did that? You take x minus 3 and set it equal to 0. X would equal 3. Plug the 3 back in. 3 minus 3 would be 0. Remember, this is shifting right 3, and it's not shifting up or down. So the vertex is 3, 0. Now, if we were to graph this 5, 2, 4, 1, and 3, 0, and we just graphed it like that and just said, oh, it's going to continue down, we would be in trouble because we wouldn't have graphed our V shape. So what you want to do is you want to make sure that you find your vertex and make sure that we don't need any more. So we want to go one more point so that we can see both sides of the vertex. So if I plug a 2 in there, 2 subtract 3 is negative 1. The absolute value of negative 1 is 1. And so now I can replot those and notice that it is going to go back up. Okay, so I now do see the part of the v that I do need to have on my graph. So be very, very careful when graphing absolute values. Okay, now let's graph the next one. Now the next one is just a line, and I know this because it doesn't have any absolute value symbols. So x and y equals 1/2 x minus 2. So I'm going to plug in values that are greater than or equal to 5. So that's going to be a closed circle at 5, and we'll do 6 and 7. So 5 times 1/2 is 5 halves, minus 2, which is 0.5. 6 times 1/2 is 3, and 3 subtract 2 is 1. 7 times 1/2 is 3 1/2 minus 2, which is 1.5. Now we're going to go over here and graph that. 5 and 0.5, there's a closed circle there. 6, 1, and 7, 1.5. And I want all the values to the right of those because I want them to be bigger or greater than or equal to 5. All right, so that's graphing piecewise functions. Remember, there are no shading. It's not a dashed or dotted lines. We are simply graphing part of a graph, and I'm telling you which values to use. All right, now here's a third example. This is called a piecewise function, but it's also called a step function. Okay, and you're going to see why in a second that this is called a step function. All right, so this says f of x equals 3. So we want to make a table for each one of these. I'm going to color code them, but I only want to graph between 0 and 2. So x is 0, open circle at 0. Then I want 1 and 2, I want a closed circle. Okay, and it says y is equal to 3. Well, that simply means no matter what your x is, your y is always going to be 3. Then you come over here and you graph that part of the graph. So we go 0, 3, open circle. It's a little off. 0, 3, open circle, 1, 3, 2, 3. And 2, 3 we had a closed, and we'll make a line between them. Okay, then we'll go to the second function, which is f of x equals 1. So we'll use x and y equals 1. And the x values we want to use are 2, 3, and 4. And 2 is an open circle because we want it to be greater than 2, but not equal to 2. And 4 will be a closed circle because we want it less than or equal to 4. And y equals 1 means that no matter what no matter what x value you have, this y will always be 1. Then we come over here to our graph. 2, 1, open circle, 3, 1, 4, 1, and make a line. Okay, and then we'll do the last one. Okay, and the last one says when y equals 5, graph between 4, where x is greater than 4, but less than or equal to 6. So the x values we would want here are 4, and it needs to be an open circle. 5 and 6 would be a closed circle. And no matter what value x is, because it says y is equal to 5, y will always be 5. Okay, so then we come over here and we go 4, 5, open circle, 5, 5, 6, 5, closed circle, draw a line. Now what you should notice about these is that they're all horizontal lines because remember y equals a number is always a horizontal line. These are called step functions because they look like a step. They look like steps on stairs, okay? I could walk up this flight, and then I could go up to the red, and then I could move over to the black. And so it's like I'm walking on stairs because they're horizontal lines. This is just another example of piecewise functions because I'm only graphing a piece of every one of those horizontal lines. Now remember that when you come into class tomorrow, remember that these are not inequalities and that we don't have shading or dashed lines, but we're graphing pieces of graphs. All right, that's it. We'll catch you later. Bye.